All right, this lesson is on adding and subtracting radicals. So first of all, in order to add and subtract radicals, just know you have to have the same radicand. What I mean by saying radicand, the number underneath the square root symbol, the number is called radicand. So that 5 is a radicand. It acts like a variable when you add and subtracting radicals. You have to have the same radicand in order to add and subtract them. If they have different radicands, you can't add and subtract them. So all these have the square root of 5. So all these have the same radicand. So it acts like variables. So if I give you 3 square root of 5 plus 5 square root of 5s, take away 3 more square root of 5s. Or 3 plus 5 will give you 8. Take away 3 more. So 3 plus 5 square root of 5 will give you 8 square root of 5. Take away 3 more square root of 5s. So 8 take away 3 will give you 5. So it gives you 5 square root of 5. So it's kind of actually just like a variable. So as long as you have the same radicand, you can add and subtract them. Again, if you don't have the same radicand, you should first see if you can make them have the same radicand. And then if you can't, then that means it just can't be added any further. Look at number 2. It's pretty simple. It gives you 9 square root of 3 plus 2 square root of 3, take away 2 square root of 3. So, truth be told, if I gave you 2 square root of 3, take away 2 square root of 3, these two cancel each other. It be 0 square root of 3s. So our answer is 9 square root of 3s. And that's how it works. The next one, it's 7 square root of 2 plus 6 square root of 2, take away 5 square root of 2. So 7 plus 6 will give you 13 square root of 2s, take away 5 more square root of 2s. So 13 square root of 2s, you take away 5 square root of 2s. Plug and calculate 13, take away 5. You just need numbers in front. So 13, take away 5, gives you 8. So give you 8 square root of 2s. So our answer is 8 square root of 2. You might say 8 radical 2. But yes, that's what the answer would be. Notice all these have the same radicand. Now, we'll go to number 4. All the radicands are different. One is square root of 3. The radicand here is 49. And the radicand here is 48. They all are different. So as of right now, we can't add them. However, there may be a way we can rewrite them so that we can add them. For example, I know the square root of 49. Square root of 49 is simply 7. So this is really 3 square root of 3. Take away 3 times 7 plus 4 and the square root of 48. Now, the square root of 48 can be simplified. If I think about this, what are some numbers that go into 48? Well, I know 48 is really 4 times 12. So I can call this 4 times 12. And truth be told, 12 is not can be broken down further. So I can really call this plus 4. And then 12 is really 4 times 3. So I call that 4 times 3. The neat thing about radicals is if you have the same numbers underneath that radical, you can reduce it as long as you have the same power. So what that means is if that says square root, I'm looking for 2 identical numbers underneath that, and I can take it out. Had that been cube root, I'd be looking for 3 identical numbers. So looking at this, since I got 2 4s there, I can call this 4. These 2 4s now have the right to come out of the radical. And outside the radical, those 2 4s become 1 4 outside. So it gives you 4 times 4 square root of 3. So whenever you have the same 2 numbers underneath the radical, they are now allowed to come out of the radical and be outside. Now you already had a 4 outside, so you got a second 4 outside now. So this is really 16 square root of 3. So what we have is this is coming down. Just 3 square root of 3. Take away, but 3 times 7 is really 21. So I'm going to call that 3 times 7, 21. So I got 3 square root of 3, take away 21, plus 16 square root of 3. If you notice, both of these have the square root of 3 now. So these are like terms. They basically act like terms. we can add them up. So 3 square root of 3s plus 16 square root of 3s will give you 19 square root of 3s. You got to subtract 21 on the end. Generally, we like the number in front and the radical coming at the back. I don't think there's a hard rule on that. So I would generally write it as negative 21 plus 19 square root of 3, only because it can be confused whether or not that 21 is underneath the radical or not. So generally, if you have a number and a radical, I'll write the radical second. So that was negative 21 that comes in the front. All right, let's go to a new one. Here's number 5. Number 5, you have 5 square root of 2. Take away square root of 25 plus 3 square root of 8. So 5 square root of 2 doesn't change, but square root of 25 does. Square root of 25 is just 5. So let's take away 5. So square root of 25 is 5. Plus 3 square root of 8. Now square root of 8 is not a prime number. Since 8 is not a prime number, I can rewrite it as 4 times 2. So if that's true, I can break down 4 to be a prime number. I can call this 5 square root of 2, take away 5, plus 3. And then 4 is really 2 times 2. And then it's still a 2 underneath there. So you multiply all that back together, it gives you back your 8. So 2 times 2 times 2 gives you back your 8. No matter what, these numbers underneath should always lead you back to the number you came from, unless you end up having to take one out, like I took one out there. And remember, since this is square root, I can take 2 identical numbers, become 1 number outside. So these 2 2's become 1 2 outside. So I'm going to rewrite these 2 2's outside of the 3. So it's 3 times 2, square root of 2. These others just come down. So what I have now is 5 square root of 2, take away 5, plus 3 and 2 is 6. So it's 6 square root of 2. Now you should notice I got 2 like radicals. They both have the same radicand. Both have square root of 2. So I can combine those. 5 square root of 2 plus 6 square root of 2 gives me 11 square root of 2. Then my takeaway 5 just comes on the end. I'm going to rewrite it with my 5 in front though. So negative 5 plus 11 square root of 2. You may want to know why it's plus. Since it's positive, any positive number has a little hidden plus sign up there. So any positive number is understood with a little plus sign there. So I call it negative 5 plus square root of 11. All right, give you 1 or 2 more, and then hopefully you feel like you have a good understanding of it. And the next one, number 6, it says 7 square root of 6, take away 2 square root of 9, plus 2 square root of 54. Now none of these have the same radicand right now. So I want to find out if I can simplify any of these. Square root of 6, 6 is really 3 times 2. And square root of 9, I just know that that is 3. So that's 2 times 3. That's what the square root of 9 is. It's just 3. And the square root of 54, 54 is really 9 times 6. So it's going to be 2 outside the radical. So 2 to the square root of 9 times 6. So 2 and 3 are both prime. Since they're both prime, and neither one of those numbers are perfect squares, none of those numbers can come out of the radical. So I'm going to just go back and call it the square root of 6. So just 7 square root of 6. 2 times 3 is 6. And if you recognize that 9 is a perfect square, you can square root it. But if not, I'm going to break it down to be 3 times 3. I'm going to break down that 6 to be 3 times 2. It's going to be 2 square root. 9 becomes 3 times 3. 6 becomes 3 times 2. So from there, what I have is this. So these 2 3's become 1 3 outside. I got a third 3, but it didn't come out. So only these 2 get to come out. So it becomes 2 times 3. And underneath is still 3 times 2. So it's 6 square root of 6. And these just come along. So it becomes 7 square root of 6, take away 6. So here are my like radicals again. So 7 square root of 6 plus 6 square root of 6 is 13 square root of 6. Then let's take away 6. So I'll write my final answer as negative 6 plus 13 square root of 6. And that's it. Hope that's enough for you to understand exactly how to add and subtract radicals. That's all I have. Good luck.